In this lesson, we're going to learn our last way of solving systems that we're going to do in this chapter, and that's by elimination. You'll notice for problem 4 that both of our equations are in standard form. This is actually important for elimination. We need both equations to be in standard form, so if they aren't, you need to put them in standard form. So as I do this one, I see that I have 2x plus 3y equals 12 and 5x minus 2y equals 11. So I'm going to try to eliminate one of the variables by getting rid of either the x's or the y's. What I mean by eliminating them is I want to make them be opposites so that I can add them together and they add up to 0. How I would do this for the first problem, let's say I wanted to eliminate the y's. My coefficients on my y's are 3 and negative 2. So I'm going to try and find a common number I could make both of them in order to add them up to 0. When I think of 3 and 2, I know they could make a 6, right? They both go into 6. And so I'm going to try to make that top 3 turn into a 6 and that bottom 2 turn into a negative 6. And so what I would do is, in order for that to happen, I would times my top equation by 2. If I times everything by 2, 3 times 2 is 6, so I would have a 6y there. My bottom equation, my y value is already negative, so I would just times by 3, because negative 2 times 3 makes a negative 6y. And when I add those together, I would get 0. Thus eliminating that variable. So I'd go ahead and distribute that 2 to all 3 parts though, not just the y's. So I'd rewrite my top equation as 4x plus 6y equals 24, and I'd rewrite my bottom equation as 15x minus 6y equals 33. Now you look at your equation and make sure that you actually did what you wanted. Are my y's going to add up to 0 when I add these equations? And they are. So you literally add top to bottom. 4x plus 15x is 19x. My y's add up to 0. 24 plus 33 is 57. Next step would be to divide both sides by 19. And I would find that x equals 3. And that's normally the easier variable to find as the first one. Now what I'm going to do is I'm going to take one of my original problems and substitute 3 in for x. So I'm just going to copy the first one. 2x plus 3y equals 12. And where that x is, I will replace that with the 3 I just found. So I end up with 6 plus 3y equals 12. So we go ahead and solve this equation for y. We'd have 3y equals 6. So I find that y equals 2. So these two lines intersect at 3, 2. There's elimination. Hopefully you're remembering this because you did this quite a bit in Algebra 1. My last problem I have is has n's and a's in it. So same idea, I want to keep them in standard form. Really, if I don't know which variable is my independent and my dependent variable, because I'm assuming these a's and n's represent an actual value of some kind, if I don't know which one is on the x-axis and which one's on the y, I would just go alphabetically. So if I want to put these in standard form, I'm just going to rewrite them in alphabetical order, because that's how I would write my answer for this. From here then, I'm going to try to eliminate either my a's or my n's. I could make my a's, I have a 5 and a 7 as coefficients. I could turn them into a 35 and negative 35. I'm going to also look at my n's. I have a 2 and a 6. I could turn them into negative 6 and positive 6, right? Because I know 2 could become a 6. So I'm going to choose that because that seems like the easiest option. I would times my top by negative 3, because negative 3 times 2 is a negative 6, and they would add up to 0. So you distribute that negative 3 to all 3 parts. So I end up with negative 15a minus 6n equals negative 42, and then my bottom equation is going to stay the same. I didn't actually have to change that, and that's going to happen sometimes. So as I decide to add these, I look at my n's. Are they actually going to add up to 0? They are. I have negative 8a equals negative 32. So when I divide both sides by negative 8, I get a to be 4. Then when I try to substitute, I'm going to take this 4 and I'll just pick my top equation. Doesn't matter which equation you pick, they both work. And where the a is, I'm going to put a 4. So I have 2n plus 20 equals 14. and minus 20 from both sides, I'd have 2n equals a negative 6. And then I divide both sides by 2, so n equals negative 3. So my ordered pair, because I'm going to go alphabetical because I'm not sure which one's the independent and dependent variable, I would say is 4, negative 3. Hopefully that is a quick refresher for you on the elimination method. And we've done all three now.